for the brief cosmology segment for today. Again, if you view the content on BitChute, don't forget to leave us a comment. Tell your friends and foes about us over there. Thanks to our new subscribers over on BitChute. Most of all, don't forget to press like and subscribe on YouTube. Don't forget to check out our playlists, youtube.com/smashamash/playlists. There's lots of content besides the daily space weather videos, so check it out. And this is today's cosmology segment. First thing we'd like to talk about is Centaurus A. So Centaurus A is an interesting composite galaxy indeed. And you may see some chaotic structures within that galaxy, some dust lanes and some rather irregular looking features. We can also see an apparent jet coming out of the galactic core in this sort of a fashion. And you can see something similar to the Milky Way galaxy's Fermi bubbles out here. And what you're looking at here is it's a composite image. So we've got various different observatories looking at this. And what you're looking at here are, so the ESO is visible. That's the white colored portion. The apex, which is a 747. Now that's the Sophia, rather. So the apex would be orange, Chandra is blue, Spitzer is red, that's infrared light. And I would note that the magnetic field lines are actually parallel to the dust lanes on the outside of the galaxy and distorted near the center. So this is believed to be a recent galactic merger, which is why the center portion, the main disk of the galaxy, looks quite distorted here. Great view there of Centaurus A. This is the APOD, the astronomy picture of the day. You can go check it out yourself at apod.nasa.gov. Today's featured astronomy picture of the day of Centaurus A. Today we're not going to pick any random numbers. We're going to look at NGC 6544. Now, this particular globular cluster in the new general catalog, entry number 6554, is located actually quite close to the galactic disk, the galactic plane of the Milky Way. And if we zoom way in, again, this is located at about 8,000 light years. And you'll find a recent article in phys.org about NGC 6544, this globular cluster. And basically what the article is about is the chemical composition. So the metallicity was interesting, the aluminum to iron ratio. They did a chemical study of 23 of the stars, I believe the ones in that rectangle there. So perhaps have a read on this if you like. It's in phys.org's Astronomy and Space section. The research found that the analyzed red giant branch stars have mean metallicity of about negative 1.44 and alpha element abundances at levels 0.2. When it comes to the asymptotic giant branch stars, these values were measured to be negative 1.66 and 0.25 respectively. According to research, 14 out of the 23 investigated stars showcase distinct chemical patterns, which indicates they are so-called second-generation stars. In general, multiple populations within globular clusters refer basically to a first generation and second generation of stars. Studies show that first generation stars pollute second generation with processed material, creating different subpopulations in globular clusters. The composition of the second generation stars varies almost at an individual cluster level. And one of the main issues we're talking about here is the aluminum to iron ratio. So metallicity is very important in the chemical structures in the realm of cosmology. And that's pretty much all I have to say about that. And that's today's cosmology segment. Thanks for tuning in, folks. We'll have to say goodbye to Twitch. we'll bring you back for the meteorology segment.